Hello, in this video I will go over more in depth of a right triangle and how to use Pythagorean and SOHCAHTOA. So on the previous video, you do have a little bit introduction of SOHCAHTOA and Pythagorean theorem. So yeah, let's just go more in depth. So what are right triangles? Basically a triangle with a 190-degree angle, or it has that little box symbol. So if you look at the figure on the right, it has that little box symbol. So that's how you know that's how you indicate it is a right triangle. From previous lectures, you can have an isosceles right triangle. Okay, so did you know, so SOHCAHTOA and Pythagorean theorem, did you know that if you have a right triangle, you can find missing side lengths or missing angles using SOHCAHTOA or Pythagorean theorem? This only applies to right triangle only. Okay, and then SOHCAHTOA. So you can find missing side lengths and missing angles of a right triangle by applying SOHCAHTOA. Remember, if you need to solve for a variable or the angle, that's what I mean by variable, take the inverse of both sides. So I will explain that like right now. So what is SOHCAHTOA? So it's just a little riddle to help you remember sine, cosine, and tangent. So or sine is equal to opposite over hypotenuse. Ca or cosine means adjacent over hypotenuse. And toa, tangent, equals opposite over adjacent. Okay, so if you look at these, let's look at this triangle. Well, let's say you want to find x. X is a side length, right? It is not an angle, it is a side length. So you want to solve for x. How would you do this? Using SOHCAHTOA or Pythagorean theorem? There's actually, you could actually do Pythagorean theorem or SOHCAHTOA, but let's try SOHCAHTOA. So with SOHCAHTOA, you want to find this missing side length, right? So the first step is figure out which angle are you going to use. So we have two angles. The 9, not including 90. You don't want to use a 90. So you can either use 30 degrees or 60 degrees. It's up to you. It doesn't matter which one. So I'm just going to say 60. So if you're going to use, just remember what angle you're going to use. And then the kind of difficult part is figuring out which should you use, sine, cosine, or tangent. So what you want is a known value and an unknown value. So could we apply sine? So if we try that, sine of 60, it would be opposite over hypotenuse, right? So opposite, so from the angle 60, could you tell what would be your opposite side? Opposite side length. So here's 60, the opposite side would be heading to the 4. And then the hypotenuse is 5. This is not going to work because you need to have one unknown and one known value. This gives you two known values. It will never give you x, right? So I don't think we'll have to use I don't think cosine will work, but I do think tangent will work. Okay, so you're going to do tan of 60, which is opposite over adjacent. So your opposite side is 4, and your adjacent side is, from the angle 60, your adjacent side is x. This works nicely because you have a known value and an unknown value. Then what you want to do is solve for x. So you're going to cross multiply. So 1 times 4 is 4. And then it's x times tan of 60. Okay. So hold on, let me get my unit circle. So you can use a calculator for this one. Now tan of 60, you later later on, when we go over the unit circle, you'll see that tan of 60, if you put tan of 60, it's going to give you a decimal, like an actual number. But in a unit circle, the tan of 60 is actually going to be radical 3 over 2 over 1/2, which simplifies as radical 3. I haven't gone over the unit circle, so you don't have to use exact value. You don't have to use radical 3, but later on, you'll see that 60 is one of your 30, 40, 60, 90-degree angle. And if it's a degree in your unit circle, you have you can use exact values, but I haven't gone over that. So let's just put this in the, you could just solve for x. So you're just gonna have to use a calculator. That's what I meant. So you're gonna divide both sides by tan of 60. And is 60 degrees. Okay, so now you have x equals to 4 over tan of 60. Okay, so then you can put it in the calculator. Make sure you are in degree mode, not radians. So if you put that in the calculator, I get 2.3. Okay, so x, or small length x, is 2.3. Okay, so yeah, that's how you find small x. Now let's look at this other example. Let's say you want to find an angle, an unknown angle, using SOHCAHTOA. So this is where you have to, like, the part where it says, remember, if you need to solve, take the inverse of both sides. So I'll explain that. We haven't gone over inverse, but we'll learn it later. So let's figure out what this angle, so we're gonna have to use angle x. Now we've already picked our angle, which is angle x, which is unknown. Now we gotta should we use sine, cosine, or tangent? Because we don't have the hypotenuse, this would be 5 though. If you, because it's a 3, 4, 5 triangle. But if you didn't know that, you could just apply Pythagorean to find the missing hypotenuse. So it doesn't really matter which we use, because we have all our known sides. So it doesn't matter if you use sine, cosine, or tangent. It would all work. So if we do sine, and then our angle, we said that our unknown angle is x, is equal to opposite over hypotenuse. So my opposite side is, so from angle x, what is the opposite side? 3. And then your hypotenuse, because it's opposite over hypotenuse, your hypotenuse is 5. Okay, but we just want to solve for just x, right? We have to somehow get rid of this sin, this sign. So I think this is from your algebra course. If you want to get rid of this sin, you can multiply both sides by sin inverse, because sin inverse and sin, they cancel, and you have to do it on both sides. Okay, so this cancels. So you're left with x equals sin inverse 3 over 5. And that is a degree. You could put this in the calculator. Make sure you're in degree mode. So it would be second function sin, and then to put 3 over 5. And I get 36.86 degrees. It would be 36.9. Okay, so you just found this. You could find an unknown angle, and you can find an unknown side length using SOHCAHTOA. So it's gonna be very handy in this course. Okay, go ahead and take a minute to absorb all that. Let's move on. So Pythagorean theorem. So if you only need to find missing side lengths of a right triangle, then you can apply Pythagorean theorem. So it's basically a squared plus b squared equals c squared, where a, or small a, represents leg, and small b represents leg, and small c represents hypotenuse. Remember, the largest angle goes with the hypotenuse. So if you look at this example, this triangle, why is 5 a hypotenuse? Well, 5 is a hypotenuse because if you 5 goes with the angle 90, right? If you bring a little arrow here, it goes with this little box symbol, which is a 90 degree. And 90 degree is the largest angle of this triangle, right? So yeah, so that's why 5 is the hypotenuse. So yeah, you can find missing side lengths using Pythagorean theorem. Okay, let's move on. So now let's do some practice problems. So example 1 says find the missing side lengths or missing angles of a right triangle using Pythagorean theorem or SOHCAHTOA. So on this example, we have to find two things. The missing hypotenuse, right? And then C, big C. And then this is like a Greek symbol. I think it's called lambda or alpha, but it's that small angle. I forget my symbols for, yeah. Okay, so this is either, this is lambda or alpha. I'm not sure, I forget. And then we have to find for small c. So let's find small c. I think that would be the easiest. How would we find the hypotenuse or small c? Pythagorean theorem, right? Because it's a side length. So you can apply a squared plus b squared equals c squared. So we do have both of our legs. One of my legs is 4.32 and another leg is 2.62. So let's just put it in the formula. So it'd be 4.32 squared plus 2.62 squared equals the c squared. Go ahead and put that in the calculator. I'm just going to put it exactly like that. That is going to be 25.5268 equals the c squared. Okay, and then solve for small c by taking the square root of both sides. And that is going to be, put that in the calculator. I get 5.05. Since everything 5.05252. Since everything is in two decimal place, let's just round it to two decimal place. It would be 5.05. Okay, so small c is 5.05. Okay, so we found small c. Now let's find out lambda or alpha, this little angle here. So I think we'll have to use SOHCAHTOA. Should we use sine, cosine, or tangent? I think tangent will be the most appropriate because honestly, I don't think in this situation sine or cosine would work because we're finding the missing angle, not side length. So I'm just going to do tangent. So I'm going to do tan, and our angle will be alpha, or that little symbol right there. And then it's going to be opposite over adjacent. So from this angle alpha, what would be considered my opposite side? The opposite side would be pointing to 4.32 over adjacent side. So from this angle, my adjacent side would be 2.62. Okay. Okay. We're not quite there yet. We got to just solve for lambda. So I have to get rid of this tan. So how do you get rid of that tan? By taking the inverse. So multiply both sides by tan inverse. Okay. So on the left side, this cancels. So you're left with lambda, which is what we want. And then on the right side, you're left with tan inverse of 4.32 over 2.62. Okay. Yeah, now what we're going to do is we're going to put in the calculator. And I get 58.763. So lambda is going to be, let's just round it to 2 decimal places. It would be 58.76 degrees. Okay. So as you can see, that is example 1. Go ahead and absorb all that. Let us move on to example 2. Okay, so example 2 says find the missing side lengths or missing angles of the right triangle using Pythagorean theorem or SOHCAHTOA. So in our case, we have to find the missing angle. I forget what this symbol is called. This symbol right here. So that's an angle. So what should we use? Should we use SOHCAHTOA or Pythagorean? We would definitely have to use SOHCAHTOA because with Pythagorean, it's just side lengths. We need an angle. So I think I'll do tangent. I don't think in our case sine and cosine will not work because we don't know what the hypotenuse is. We could find the hypotenuse, but it's just more work. So I think it's just best to do tangent. So we're going to do tan of your angle, which is this symbol. Forget what it's called, which is opposite over adjacent. So from this angle, the opposite side would be 0.6 over the adjacent side would be 0.8. Okay, we're not quite there yet. We just have to solve for this symbol. So I have to get rid of this tan. So to do so is multiply by both sides by tan inverse. Okay, so this cancels. So you're left with theta equals to tan inverse of 0.6 over 0.8. And that gives you 36.869. Let's just round to 1 decimal, so 36.9 degrees. So your unknown angle is 36.9 degrees. Okay, go ahead and absorb or pause. Okay, let's move on. So on example 3, it looks like we have to find the missing unknown angle, right? So we got to find out what this unknown angle is. And we're going to use, so definitely SOHCAHTOA. And in our case, since we have all the side lengths, it doesn't matter which one you use, right? I could do sine, cosine, or tangent. Let's just do sine. So sine of your angle, which is opposite over hypotenuse. So from this angle, the opposite side is 3. And then your hypotenuse is radical 10. Okay. You don't have to rationalize the denominator because you could just put it in the calculator. So next, what I would do is take the sin inverse because we want to get rid of the sin, right? So this cancels. You're left with the angle. And then you're left with sin inverse of 3 over radical 10. And that gives you 71.565 degrees. Let's just round to 1 decimal. So it would be 71.6 degrees. Okay, so that is your unknown angle, 71.6 degrees. Okay, I will stop here. We will finish the last 3 examples in another video, followed by a quiz.